Hello, welcome to 1.3, which is covering point slope form and parallel and perpendicular lines. So we're going to talk about writing an equation in point slope form and then also writing equations of parallel and perpendicular lines. Point slope form. To write an equation in point slope form, you need both the slope and the point, hence why it's called point slope formula. So point slope formula is written as y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is the point that we know. So let's look at an example here. We are going to write the equation of the line in point slope form given the information. Okay, what we know is that the slope is 2 and it passes through that point. So again, the equation is y minus y1 equals m times x minus x1. So this is m and then this is x1, y1, and we're just going to plug that in. So y minus 1 equals 2 times x minus negative 3. So instead of writing minus negative 3, I'm going to write plus 3. Okay, and that is your equation in point slope form. All right, here's another example where I'm given 2 points. So the first step that I have to do is to find the slope. So I have x1, y1, x2, y2, and we know that the slope formula is y2 minus y1 over x2 minus x1. So I have 4 minus 2 over negative 1 negative 1 minus 3. So that gives me 2 over negative 4, which is negative 1/2. Okay, so that's my slope. And then I can use either of these points for my point in point slope form. So remember, point slope form is y minus y1 equals m times x minus x1. So y minus, if I use my first point, 2 equals negative 1/2 x minus 3. Okay, but like I said, I could use the other point. So I could also have y minus 4 equals negative 1/2 x plus 1. Because again, I'm subtracting that negative 1, which would make it a plus 1. Okay, so again, first step was finding the slope given those 2 points, and then using one of those 2 points to write the equation in point slope form. So either of these would be an acceptable answer. Okay, so parallel and perpendicular lines, if we look at those, parallel lines mean that those 2 lines are never going to intersect. So when we talk about the slope of those 2 lines, the slopes are equal. So if I look over here, you notice that, let's do that in a different color. The slope here is 2, the slope here is 2, right? So they have the same slope, and that's how we know that those 2 lines are parallel. When we talk about perpendicular lines, again, perpendicular means to intersect at 90 degrees. So you can see that little box there that's telling me that they make a 90-degree angle. And we can tell by looking at these slopes, I have 2/3 and a negative 3/2. Those are not the same. Okay, so when we talk about perpendicular slopes, they need to be opposite reciprocals. So one slope needs to be positive and one slope needs to be negative. One has to be increasing, one has to be decreasing. And by reciprocal, if we look at this, I have a 2/3 and then I flip that, a 3/2. So I would, in this example, I have a positive 2/3 and negative 3/2, and that's how we know that they are perpendicular. Okay, so let's look at an example. We have two equations. These are both in slope-intercept form, and we're going to decide if they are parallel, perpendicular, or neither. So remember, slope-intercept form is y equals mx plus b. We're focusing on this m, so in this case, m is 3 for this first one. In the second one, m is 1/3. So while they are reciprocals of each other, we do not have one positive and one negative, which we would need for them to be perpendicular. So the answer to this one would be neither. They're not the same, which would make them parallel, and they're not opposite reciprocals, which would make them perpendicular. Here's another example. We're going to do the same thing. So I want them again in slope-intercept form so I can look at and identify the slope. So in this case, my slope is -5/2. In this case, this is not in slope-intercept form. So the first thing I have to do is rewrite this. So like we practiced, we're going to bring the 2x over. So I get -5y equals -2x plus 8. And then I need to divide by -5. So I get y equals 2/5 x minus 8/5. And remember, improper fractions are okay. We don't have to worry about figuring out what that fraction is. We leave it as is. So in this case, now I know that my slope is 2/5. So if I look at 2/5 and -5/2, they're not the same, so it can't be parallel, but they are opposite reciprocals. One is positive, one is negative, and they're reciprocals of each other, meaning one is the flipped version of the other. So these two lines would be perpendicular. Let's do one more example. So again, first thing I have to do is get these into slope-intercept form. So I'm going to, for this first one, all I have to do is divide by 4 because the x is already on the right side. So I get y equals 3/2x plus 2. So my slope in this one is 3/2. Second one, first thing I need to do is bring the 3x over. So I get -2y equals -3x plus 12. Divide everything by -2. So I get y equals 3/2x minus 6. So now I look at this and my slope is 3/2. Okay, so you should notice right away that those slopes are the same. They're both 3/2, which means that the lines are parallel. Okay, so now in this example, we're going to write the equation of a line in point-slope form given the following information. So remember, point-slope form is y minus y1 equals m times x minus x1. And to be able to do this, I need the slope, which I don't have currently, and a point, which I do have, the point. So what I need to do is take this information and figure out what slope I'm going to use for that equation. So if it's parallel, remember parallel means same slope. So I'm going to take this 3y equals 6x plus 3 and put it into slope-intercept form. So I'm going to divide everything by 3. So I get y equals 2x plus 1. And so the slope of that is 2. And since they're parallel, which means same slope, I want m equals 2 for my slope in my point slope form. So now I'm going to use this point that's given to me and the slope that I found, and I'm going to plug in for point slope form. So it's going to be y minus 6 equals 2, that's that slope I found, x plus 2. So that point goes through, that equation goes through the point, -2, 6, and is parallel to this line. And again, the reason we know that it's parallel is because we used the same slope. Let's look at one more. Same idea, but now it's going to be perpendicular to this. So perpendicular, we're looking for opposite reciprocal slope. So first let's solve to get this into slope-intercept form. So I'm going to bring the 4x over. So negative 2y equals negative 4x plus 8. Divide everything by negative 2. And I get y equals 2x minus 4. So my slope here is 2. But since I want it to be perpendicular, I need the opposite reciprocal of that. So first thing I look at is, since m is 2, I need, it's positive 2, I need this, the perpendicular one, to be negative. And 2 is really 2 over 1, so I need this to flip. So the slope I'm going to use is negative 1/2. And then I'm going to take my point slope form, y minus y1 equals m times x minus x1. Here's my x1, y1, and here's the slope I'm using. So it's going to be y minus 4 equals negative 1/2 x minus 1. There's my final answer. And that is it for 1.3.